Okay, we're going to be looking at a new unit here. We're looking at particles and various models for particles. I almost said marbles because I was looking at that picture over here. But marbles can be an example of representing what particles might look like if we could actually see them. We'll talk about sizes and everything a little bit later, but what we're going to do is we're going to use this idea of particles to try to explain a bunch of things that we see and experience around us. Everything from solids to the air that we breathe to liquids, why they behave the way they do, what's different about them, and we're going to do several experiments that will make you go, hey, what's going on here? I really want to know. Okay, so let's use a silly example for now. So there's a little baby with his little doggy, really cute. Really? And then something not so cute happens. Uh-oh. All right. Now, if you're walking on the street and you come across something like this, okay, let's say it happened relatively recently. When you walk past it, you'll probably smell it, okay? If you can smell it, now what exactly is smell? And so if you have to think about and understand what smell is, well, I'm going to tell you something you're not going to be very happy about. If you can smell something, that means particles of that substance are actually inside your nose, okay? If they're inside your nose, they're probably inside your mouth as well and inside your ears. But our mouth, how come we don't taste something when we smell it? So if somebody's cooking something in the kitchen, we can smell it, but we don't taste it. It's because our tongue and nose receptors are different in terms of their sensitivity. Our nose is much more sensitive, able to detect small amounts of particles in the air. So the point is, if you can smell something, that means those particles are actually inside your face, okay? So what does that mean about this? If you walk past a little mess like this, yes, that means small particles like this are actually getting inside your nose and you're detecting it and you're smelling it. Now, normally I know if I touch this stuff and then don't wash my hands and eat, I could probably get really sick. So why don't I get sick if these particles are actually getting into my nose? And the answer is our noses are so sensitive that we can actually detect these things exist without actually there being enough bacteria to actually make us sick. So smells. So, you know, when you smell something and then you plug up your nose like this and then you're like, oh, it's so stinky, and you start to breathe just through your mouth, what happens is those particles are still getting onto your mouth, but I guess it's fine because you can't technically taste it unless enough of it actually lands there, which it probably won't happen. Okay. Oops. Okay. I don't know who that guy is. All right. Forget about him. So looking at and thinking about substances, just a few things here. Everything in general can be categorized into solids, liquids, and gases. You've probably heard of that before. So we're going to start real basic, and then later on we'll get much more advanced to look at some really interesting things that are actually happening. So all the stuff we see and feel in the world is called matter. Okay, M-A-T-T-E-R. Right? Does matter matter? Yes, it does matter. Types of matter are called substances. Water, gold, leaves, brick, anything else, anything that you see around you, anything that's in your room, anything that's in the classroom, those are all types of substances and matter. And we can make detailed observations about different substances. There are some things that are kind of strange, like foam. Foam seems like there's some solid in there, yet it changes shape really easily, and there's also some gas in there. Or is it like a liquid that's really slow moving? Water and syrup are very different, right? If I pour water, it just falls out. If I pour syrup, it seems to fall really, really slowly. It's more viscous, we can say. So lots of different observations, lots of different types of substances. So we're going to try to observe a whole bunch of these things. Water is really interesting as well, too. When it freezes, it actually expands. And I'm going to show you a little video of an experiment, but we're not going to do that because it's a little bit dangerous. You'll see in the video why we think it's dangerous. Okay, really quickly, thinking about theories. Before I go on, pause the video and try to use the word theory in your own sentence. Make up your own sentence using the word theory. Okay, I'm pausing now. All right, did you make the sentence? All right. So how did you use it? Chances are you use the word theory to mean something like a guess. I have a theory about who took my socks. Okay, something like that. In science, the word theory is a lot more meaningful. And it's more than just simply a guess. So when we say a theory, we're talking about looking at all the scientific evidence for a particular thing, and trying to put it all together into one big idea that governs a bunch of other ideas and allows us to make some predictions. So ideas used to explain the evidence compiled together are called theories. And so to give you an example of a theory, so you all accept that we have electricity, right? You have lights. We're very lucky. We're not like back in 200 years ago where we had to use candles for everything. We have electricity. I can charge my computer. I can charge my iPhone. I don't have to be walking around in the dark all the time, even though it's nighttime. All of that, all of our understanding of electricity is based on something called electromagnetic theory. So it's not a guess. It's not an electromagnetic guess. If it were a guess, then we wouldn't feel safe powering up an airplane and trusting some guys or some women to drive the entire airplane and put everybody's life in danger. So we base all of our calculations. It's really smart people who do this stuff are basing it off of electromagnetic theory. So it seems like it's pretty strong. Here's another one. Atomic theory. The idea that everything is made up of atoms. There are very few, if any, scientists around the world who say things like, no, I don't believe in atoms. Atoms don't exist. I can't see them, therefore they're not there. But atomic theory is a very, very strong idea, and it governs a whole bunch of things that we actually do and live by. Okay? So atomic theory, the idea that things are made of atoms, it's oversimplified, but it's important. How about this one? Who's that supposed to be? Newton. Okay, have you heard of gravity? Yes. Have you ever met anybody that says, I do not believe in gravity? That would be silly, right? If you don't believe in gravity, then go up to the 3rd floor and jump off and see what happens. No, don't do that, because that's really bad. They might actually break a leg or something like that. Okay, but gravity is not called we still call it the theory of gravity. What is it? Gravitational theory. Gravitational theory. Here's the weird thing about gravity. You can't actually see it, but you can see the effects of it. Same thing with all of these. Electromagnetic theory. I can't see little particles of electricity moving from one place to another with my own eyes, but I can see the evidence that that's actually happening. Same thing with atoms and with particles. Particle theory is what we're talking about as well too. Here are some other terms that come up in this entire thing. Make sure you have some notes down and post a question about anything that's come up here. Gravitational theory, atomic theory, electromagnetic theory, evolutionary theory, particle theory. These are all scientific theories that we base our understanding of the world on. Okay, post any questions that you guys have.